June 25. A strange object from deep space passes through the inner solar system. It dives toward the sun, swings past Mars, and disappears, as fast and silently as it arrived. It's not from here, and scientists say it's only the third object like this ever seen. They named it C-2025N1, Atlas, a 20-kilometer-wide icy traveler on a hyperbolic path, meaning it came from interstellar space, and it's never coming back. But what exactly is it? Where did it come from? And why are astronomers comparing it to Oumuamua, the mysterious, fast-moving object that made headlines in 2017? To understand what just happened in 2025, we need to go back to where this story really begins. You're watching Dominion Hour, where we explore the deepest questions in space, science, and time. Let's unravel the mystery. The first interstellar object ever detected came in 2017. It was named Oumuamua, meaning a messenger from afar arriving first. It appeared suddenly. No tail, no reflection, no explanation. It wasn't round. It was shaped like a cigar or a pancake, and it was tumbling, accelerating, twisting. Astronomers had never seen anything like it. Unlike comets or asteroids from our system, Oumuamua didn't orbit the sun. It passed through, looping around, then speeding away, as if something pushed it. No gas, no ice. But it moved. Harvard researchers even published a paper asking, could it be artificial? Not a spaceship, but maybe a probe, or debris from a long-dead civilization. The truth? We'll never know. It came and went so fast we never got a clear photo. But it changed everything. It proved interstellar visitors were real, and it opened the door for what came next. In 2018, just 2 years after Oumuamua, astronomers detected a second interstellar object. It was named 2I Borisov, the second interstellar object ever observed. But this time it looked familiar, a true comet. Unlike Oumuamua, Borisov had gas jets, ice vapor, and a beautiful tail, all glowing in reflected sunlight. But its speed and trajectory? Not from here. Borisov confirmed what Oumuamua hinted at. Interstellar objects are real, and they don't come just once in a lifetime. It was a piece of another solar system, and it passed us by without slowing. And now, in 2025, the third arrives. Atlas. In 2000, the Atlas system detected something strange. Fast, icy, on a hyperbolic path. It was named C-2025N1 Atlas. And right away, astronomers knew it wasn't local. Unlike other comets that linger in the outer solar system, Atlas was diving into the heart of it. Estimated at over 20 kilometers wide, Atlas is more than 10x larger than Oumuamua and far more massive than Borisov. Its closest approach to the Sun will be in June 2025, and for the first time ever, we have months of warning to study an interstellar object up close. What is it really? To classify an object as interstellar, astronomers look for one key sign, a trajectory that can't be explained by the sun's gravity. In other words, its path is open-ended, not looping back around like comets do, but instead on a one-way trip from somewhere else. When scientists ran orbital simulations for Atlas, they found its eccentricity was above 1, a signature of a body not bound by our star. It's like watching someone walk into a room with no door and realizing they came through the wall. There's no way Atlas was born here. So the question becomes, where did it come from? And why now? We may never know the star system that ejected it. But interstellar objects are time capsules, frozen fossils of alien places, and the clues may lie in what Atlas is made of. Based on preliminary spectral scans, Atlas appears to be icy, with elements like water, carbon monoxide, and complex organics. That's not unusual. Many long-period comets have similar compositions. But Atlas isn't bound by our system's icy Oort cloud. It's older, more pristine. It's been floating in deep interstellar cold for billions of years. That makes it invaluable. It could carry compounds formed around stars completely unlike ours, chemical fingerprints of alien suns. Some scientists hope to observe outgassing as it nears the sun. The heat will wake it up, shedding its outer layers and releasing gases we can analyze from Earth. We've never studied an interstellar object this closely. If we're lucky, Atlas might teach us not just about its origin, but about the chemical history of other solar systems. But there's more at stake than science. When people hear 20 kilometers wide, they think impact threat. That's natural. An object that size hitting Earth would be planet-altering. But scientists are clear. C-225N1 is not on a collision course. Its closest approach to Earth will be hundreds of millions of kilometers away, a safe distance by cosmic standards. Still, it's a big, fast-moving rock with a hyperbolic speed. And history shows we've underestimated orbital shifts before, especially with comets shedding mass or fragmenting. It's not about fear, it's about curiosity. What happens when an object from another star system interacts with our solar wind, with our sun's magnetic field, with gravitational pulls it's never felt before? In some ways, Atlas is a probe from another world, unintentional but full of data. And we're watching closely, because this could be a once-in-a-lifetime opportunity. Our solar system isn't a bubble. It's a node in a much larger cosmic web. Around every star is a cloud of debris, comets, asteroids, ice, and dust. Occasionally, gravitational slingshots eject some of these objects into the interstellar medium. Once free, they drift for eons, untouched, unchanged, until they cross paths with another system. That's what Atlas is. A traveler from some unknown system, maybe flung out by a planet, a supernova, or a rogue star. It's a reminder. Space is not empty. It's teeming with silent motion. Things flung into the dark, crossing billions of kilometers, unseen until they pass through a beam of sunlight and catch a telescope's eye. These objects are rare, but not as rare as we once thought. And every one that enters? It brings questions we didn't know to ask. This question comes up every time something interstellar appears, especially when it behaves oddly. With Oumuamua, it was the non-gravitational acceleration and lack of a visible tail that sparked speculation. Could it be a probe, a fragment, a light sail? With Atlas, it's different. It seems more comet-like, more traditional. But even so, astronomers will watch closely for any signs that its motion, spin, or material ejection behave unusually. Could it be an alien artifact? Unlikely, but not impossible. We must remember, every probe we send out, Voyager, Pioneer, New Horizons, becomes an interstellar object eventually. To someone else, our machines might look just as mysterious. Atlas is likely natural, but it's still a message, one we didn't send but are lucky enough to receive. A billion-year-old traveler from a place we've never seen, and now it's showing up on our doorstep. NASA and ESA have proposed missions in the past to chase down interstellar objects. But it's hard. These objects move too fast and we spot them too late. By the time we know they're coming, they're already leaving. To intercept Atlas, a mission would have needed to launch years ago, but even now, scientists are exploring whether ground-based and space-based telescopes can gather enough data to simulate an encounter. There are wild ideas. Could we one day build a dedicated interstellar interceptor, always on standby to chase down the next visitor? That's the dream. Because capturing or landing on one of these objects would be like grabbing a piece of another solar system. A time capsule. An alien fossil, Atlas, may be out of reach for a physical mission, but the next one, we might just be ready. Atlas is unique for several reasons. First, its size, an estimated 20 kilometers wide. That's massive for a visitor from another star. Second, its deep trajectory. It's not skimming by like Oumuamua or Borisov. It's diving into the core of our planetary system, crossing Earth's orbit. Third, timing. This is the first interstellar object we've spotted early enough to study for months before closest approach. That gives scientists a rare window, time to coordinate observatories around the world, to gather light spectra, thermal readings, and chemical data. It's not just a visitor anymore. It's a scientific event, one we'll remember for decades. Atlas may be the third we've seen, but it might be the first we truly understand. And what it teaches us could change how we look at our place in the galaxy. Atlas isn't alone. In fact, based on the detection rate of interstellar objects so far, astronomers estimate millions of similar objects could be drifting through the Milky Way. Many are likely too small, too dark, or too far to detect. But with better telescopes, like the Vera Rubin Observatory, we might start seeing them regularly. Each new detection helps map the structure of our galactic neighborhood, giving us hints about how planets form, how systems evolve, and how material moves between stars. These aren't just comets. They're breadcrumbs of cosmic history. Every interstellar object is a chance to study another solar system's leftovers. And if we start seeing them more often, it means our corner of the galaxy is more connected and maybe more visited than we ever imagined. The cosmos might not be quiet. It might just be vast. Here's the twist. Atlas isn't just about space. By analyzing its material, especially the ratios of carbon, nitrogen, and volatile elements, scientists can compare it to Earth's early building blocks. Why does that matter? Because some theories suggest Earth's water and organics came from icy objects like this, comets and asteroids carrying the seeds of life. If Atlas has similar compounds, it supports the idea that life's ingredients may be common across the galaxy. It connects our origins to a much bigger story. We aren't just studying a rock. We're studying how planets like ours might form elsewhere. Maybe this visitor isn't just a relic of another system. Maybe it's a preview of another Earth. Every interstellar object is like a message in a bottle, tossed across light years. It carries no words, no symbols. But inside it, ancient dust, frozen gases, atomic fingerprints of stars that may no longer exist. We may never know where Atlas came from, but we can read its chemistry, trace its orbit, and listen to the story written in its silence. These objects don't shout, they whisper. And that whisper tells us we're not alone in the galaxy, not in a life sense, but in a cosmic sense. We are part of a greater ecosystem. And Atlas is a reminder that the universe is in motion, stars dying, planets forming, rocks flung across time to land briefly in our skies. This isn't just a visitor, it's a reminder. So here we are. A 20-kilometer object is hurtling through the solar system. Not from here, not staying long, but delivering a story billions of years old. We're watching, recording, and wondering. Atlas won't crash, it won't stay, but its presence could change what we know about our galaxy forever. So the question is, are we ready for more? Because the universe doesn't stop, and the next object could be bigger, faster, closer, or something else entirely. Thanks for watching Dominion Hour. If you want more stories about real cosmic visitors, subscribe now. Comment below. What do you think Atlas really is? And don't miss what we uncover next.